The first Ferris wheel was designed by and built by an American engineer named George W.G. Ferris. Oh, that makes sense. It had 36 cars. That does not, it's just information for you. You just learned a little bit about the first Ferris wheel. That each held 40 passengers. We don't need that. This is important because we're going to draw a picture. The diameter of the wheel was 250 feet, okay? And the top of the wheel was 264 feet above the ground. Also, it took 20 minutes to complete one revolution. Okay. So let's just kind of draw. Okay, I'm not a good artist. We got a Ferris wheel. Is the Ferris wheel flush with the ground? No, so there's going to be some kind of, I don't know, stand there, but we got our Ferris wheel, okay? And here's the ground. What were you told about this? You were given that. How much is it? 250, right? That's this total length here. Also, weren't you told that the maximum, which we all agree when you're at your maximum height, you would be up there, is 264 feet above the ground, right? Okay, tell me what you know. If from here to here is 250, this is 264 feet above the ground, what's the distance from here to here then? 14 feet. Okay, let's write out some things that we know and the other things we can figure out. What's the max? The max is 264. If this is 250, we also know what the min is, right? You just told me that. What's the minimum? 14. So we're going to be able to find the amplitude and vertical shift from that. All right, would you do that for me? You can use your formula from before. Would you find both the amplitude and the vertical shift, please? I'm just squeezing that in there because I don't have a lot of room. So I got 125 for my amplitude. Now, I hope this kind of makes sense for you, because if the diameter of the circle was 250, the amplitude is going to be half of that, 125. Excuse me. All right, let's do our K. What's 264 plus 14 is 278. I divide that by 2. 139. All right. Here's the other thing. Let's figure out B. The 20 minutes to complete one revolution, that's the period, folks, right there. So what we're going to do to find B, and we'll just do ours in degrees, we're going to take 360 and we're going to divide that by 20. And 360 divided by 20 is going to be 18. Okay, now the tricky part, the H. So it kind of depends on, like when you're in a Ferris wheel, you get on, right? And then doesn't it move? And then more people get on and then, you know, so you have, and then it starts. So you don't really have to pick an H for this. I guess it would depend on where you're sitting, and we don't know where we're sitting, okay? So, or if you want to think of it as you're the bottom person, then you could use actually a negative cosine curve to start it at its minimum. But I think if I'm just asking for a sine or cosine to model the function, this is where we're going to have some different answers. I'm going to just write a sine function, and I'm not going to put a phase shift on there because it would depend where you are. So to write that, I would have y equals 125 sine, my b was 18, t, I'm not putting a phase shift on there, and my vertical shift was plus 139. Okay, now if I chose to do this, you can go ahead and use your calculator to find a table of values and graph. But here's the deal, guys. Learning what we learned yesterday, do you really need a table of values to sketch a graph? You shouldn't, okay? Because we know what the max and min is, okay? But let's plug some points in. If I did sine of 18 times 0, that would be 0 plus 139. The very first is 139, which is halfway between the max and min. That makes sense. If I plugged in 5, I'm simply putting 5 in for t. I'm going to just leave that right in there. 18 times 5 plus 139. Okay, I get 264. That's actually its maximum, okay, which if you're noticing here, I have one period sketched, so that's what's going on. 125 sine of 18 times 10 plus 139. Some of you are in your head making a prediction. It's going to come back to the middle, 139. Let's see. It started in the middle, went to its max, went to the middle. Where's it going to go next? Should go down to its bottom, but let's check. 125 sine of 18 times 15 goes down to 14, like some of us predicted. And I don't even need to put this back in. It's now then going to come back to the middle. Okay. I'm going to just do this. I'm going to fudge it a little bit. What should I make my midline? This isn't my XY axis. I'm just graphing one period. Where's the middle? 139, right? Where's the top? At our top, just go ahead and put a 264. We're just sketching a picture here. The bottom should be 14. This is not an XY axis. I'm just starting this in the middle. I'm going to just go ahead and graph 0. Well, there's 0, 5, 10, 15, 20, and I'm going to sketch a picture. Okay, so there's two different examples of modeling with sine and cosine.